I'm delighted to be joined now by Stan Farnsworth from a new company called PulseForge. Welcome, Stan, and thank you for coming in today.
Of course, good morning. This is our debut here at IPC Apex, following our exciting launch at CES just a couple of weeks ago.
Right, exactly. So just to explain to our viewers, the PulseForge is a breakaway division from Novacentrix. They were together at one point, but explain why you split the company.
Sure. So Novacentrix is our origination point. Novacentrix has been in operation altogether now for over 20 years. We started as a nanomaterials company, evolved into printed and flexible electronics, and over the course of that evolution, we developed a couple of really important business units. One related to materials through primarily electrically conductive inks, and also some continued sales and development of nano powders and formulations. But the second one that really developed as we got more into the challenges of printed and flexible electronics is related to processing those materials. And the challenge has always been processing materials at higher temperatures than what their substrates could accommodate. And that seems like a challenge for sure, but we figured out how to do that with our PulseForge tools. And over the course of time, the PulseForge product line has evolved, and we finally realized just during the pandemic that we wanted to separate that into an independent entity to really let that blossom and flourish. And so here we are now with Novacentrix continuing on, but here we are today with PulseForge Corp.
Right. So tell us a little bit how the technology works, because you mentioned there that it reflows solder and other materials at a much higher temperature. But of course, that normally sends warning bells off in people's minds. But in actual fact, it's a very safe system, for the components around it. Maybe you could explain that.
Of course, thanks. We are playing tricks with heat transfer. Mm-hmm. So using physics in our favor, it turns out that if we can apply energy quickly enough, and by quickly enough, I mean seconds or even milliseconds, then we can achieve the target temperatures on the, in this case, the solder, and achieve liquidus and get good reflow properties, but turn off the power again before enough total energy has been applied to heat the substrate and the components. So we're heating only the solder in seconds or less, and not heating the entire body of the substrate and all of the other components. And in doing that, it lets us do a couple of things, and it lets our customers who are using the tools do a couple of things. It lets them process the solders very quickly, much faster than traditional technologies allow. It lets them process large areas altogether, so we get much more scalability and throughput. And when you process large areas, you get fun effects like self-aligning components, because the surface tensions on the solder allow them to realign themselves on the pads, which is really exciting to watch. But really importantly also, it lets us and our customers use only about 15% of the energy that a normal reflow oven would use. And so it's a great way to decarbonize the supply chain and save some energy costs while we're at it.
Yeah, that's incredible, because, I mean, sustainability is such a big deal nowadays. A lot of countries are mandating that you have to reduce your energy levels. So this would be certainly one way of being able to reduce energy levels in the factory considerably.
Yeah, absolutely. And a quick tool installation, that's a very quick way to drop energy consumption. Because of the technology, there's no need to turn it on hours early to reach thermal equilibration in 10 or 12 zones. The way we're delivering the energy through light energy, it just turns on and then it turns off. It's really that quick.
What temperatures does it get up to?
So we can really readily achieve the liquidus temperature of even SAC 305. The lead-free solders, no problem at all, 200 to 300 degrees, 250 degrees C. In other applications outside of soldering, the tools that are configured for these other applications can do really crazy things like even melt glass frit. In fractions of a second, so 1,000 degrees C plus.
Wow.
Now, of course, we're not doing that on the electronics side, but the tool capabilities are certainly there.
Wow, that really is quite a very flexible range then of different applications. So, I was lucky enough to be with you up at CES to have a look at some of the things that were going on there, and I spoke to Rudy Ghosh about one of the applications we were talking about, which was really how to reflow onto materials, and wearables. Maybe take a look and see what Rudy told us. So one of the areas that seems to have attracted a lot of attention this week is on the wearables side.
Absolutely.
So how do you photonically solder onto wearable materials which are stretchable?
So that's again a great question, and this has come up multiple times with a lot of the customers that we have talked to, right? The samples that we are showing here are very thin PET. It's very, very flexible, but it's not stretchable, right? So for a lot of the things that we would work on the fabric side, on the wearable side, let's say, would need to stretch a lot more. The substrate would be something like TPU, thermoplastic polyurethane, and instead there is definitely a down the line possibility of having, etched copper on TPU. That's not what we have right now. But what we do on the Novacentrix side of our business, we have conductive inks.
Right.
And those conductive inks, by controlling the property of those, you can really make them stretchable. Now these stretchable inks can then be cured using the PulseForge technology. So you can put down SAC 305 and do the solder reflow using our PulseForge technology.
Yeah, so it's clear there, Stan, that what's happening is that they're using the combination of the PulseForge tool and, in this case, for the wearables, working on the Novacentrix inks that allow that to happen.
Yeah, and that's a really key point. Certainly the tools are dependent on having materials to process. The good news is that really almost any material can be fine. So Novacentrix has very excellent inks, and of course we'll advocate for Novacentrix inks. But we're finding that there's a lot of adaptability in the tools as well for different types of solder from many of the manufacturers. So we've been partnering and doing tests with leading manufacturers, solder providers here in this room today. We've done some publications with Indium and a couple of other folks as well, for example, using their off-the-shelf solder. So it doesn't require a special material to be able to use this new technology.
Right. Well, okay, so when I was at CES, I also asked Rudy about some of the other applications that opened up for this technology, and this is what he said. Just finishing off on the low temp solder side, that it is a real alternative, because some of the options they're looking at the moment are tin bismuth alloys or potentially ECAs, which of course they use silver flakes, which is expensive.
Yeah, and there's I'm not going to say anything that is inherently bad about those technologies, but those are being used because you cannot use the more conventional solder alloys such as SAC 305. And why cannot you use SAC 305 for a lot of these new applications, right? Because SAC 305, the reflow temperature is much higher than tin bismuth. We had some of these samples here where we show what happens to PET.
Right.
Very thin PET, you put it in an oven, it gets completely destroyed. We have a way of getting around that. So now you don't have to think about using silver epoxy. You don't have to think about ECAs, ECPs. You don't have to think about using tin bismuth. You do not have to make a sacrifice in your performance. You do not have to make a sacrifice in terms of materials that you use just because you want to design and develop new applications.
Yeah, well, of course, that clip there was actually talking about the using the tool as an alternative for low temperature soldering, which is obviously another key application for it. But Stan, I mean, you found some great applications when you were at CES. I think the one that sticks out in my mind was the guy from WAGS. Tell us a little bit about that.
Well, we loved CES. That was such a great venue for us to debut the company in the consumer electronics space because of the tremendous design that's evident there. And of course, CES is well known for that. One of the things that we learned at CES this year was the tremendous growth of wearables for animals, for pets. And we had an opportunity to talk with the good folks at WAGS. Tom Mason is their chief supply chain officer, and he spent a few minutes with us talking about the need for getting improved form factor, smaller devices, reduced weight, so that they could actually develop products for smaller animals. Right now, they're constrained only for larger 15-pound plus animals, dogs. large cats, I suppose, and the ability to have smaller, lighter form factors would enable a whole additional market segment for them with their pet wearables.
Absolutely. I mean, it's, into the toy dog market and everything. So that really would open up the market for them. So, yeah, a lot of interesting applications, and I think this has got a long way to go. So we're going to keep a very close eye on it, Stan, and we'll be having a further interview with you later in the week, which we'll be recording. But for now, I want to thank you for coming in and joining us.
Thank you very much. Nice to see you.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing PulseForge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think PulseForge.